So here we go. We're going to factor special products. Okay, now, it says, do you remember these products? We've talked about this before. Okay, A plus B times A minus B. Okay, what does that come out to be? Without doing the work. Does anybody remember that? Go ahead.
A squared minus 2.
Nope. Oh, wait, what?
Minus 2AB plus.
Okay, so he's saying A squared minus 2AB plus B squared. Okay, anybody disagree? Okay, Kaylee, what do you think it is?
A squared minus AB plus AB, and then...
That would cancel out. Now, I'm not asking you to factor in your head. You're supposed to have these memorized, right? Okay, if it was, and again, you don't have to. You don't have to. You can do the foiling like Lila said, but the idea behind the special products is for you to memorize the setup. You have a question?
A squared minus B squared.
A squared minus B squared. So here we go. So here are the two things that we think it is. So we'll FOIL it out just to verify. So A times A is A squared. A times negative B is negative AB. B times A is positive AB. B times negative B is negative B squared. That cancels, so our answer is A squared minus B squared. So it's not this, it's that one. So that is our special product. So every time you see A, now again, you should be able to do this mentally. Every time you see A plus B times A minus B, you get this. Period. Okay? So, that's one. Look at our next one. Now we have A plus B times A plus B.
A squared. No, it's not. A squared plus 2AB plus B squared.
So A plus B times A plus B. Nathan claims it is, say it again, A squared plus 2AB plus B squared. Anybody have something different?
No.
All right, so let's FOIL it out to verify. And again, that's just memorization. You should be able to go right from here to here by memory. Okay? Now, let's FOIL it out just to make sure. A times A is A squared. A times B is AB. A times B is AB. And B times B is B squared. Combine my like terms here in the middle. I have A squared plus 2AB plus B squared. So, Nathan was correct. And again, this is just a review. That's why we're kind of going quicker through this. You should have this from memory. And again, but notice I can FOIL that out and have any answer I want. Okay? And let's look at the last one. We got A minus B times A minus B. What's the special product? A squared minus 2AB plus B squared. All right, let's take a look. Okay, so JD thinks it's A squared plus B squared. All right, A times A is A squared. A times negative B is negative AB. Negative B times A is negative AB. Negative B times negative B is plus B squared. Combine your like terms here. A squared minus 2AB plus B squared. So, Braley was right. And again, the idea though is not to FOIL, is to go straight to here. If you have to FOIL, it's fine. Okay? Now using that, we're going to factor. The difference of squares. So the first one is difference of squares. So example A, I need you guys to stop talking so we get through this. x squared minus 49. Okay? Now, I want to show you two things. And this will probably take up our whole time, but I just want to show you this. The difference of squares, if I was to factor this normally, rooftop or no? No rooftop. So what do I do first? Parentheses, then the x's, and then I'm going to look at what? Okay, so I'm going to look at the negative 49, and I need to find factors of negative 49 that equal what? First of all, it can't be x. We can't have two numbers equal an x value. It's got to be 0. Is there an OI term here? Is there an x term? No. So it would assume that x term is 0. So I need to find factors of negative 49 that equal 0. 7 times 7 or 7 times negative 7. Because 7 minus 7 is equal to 0. Okay, so x minus 7, x plus 7. So that would be the work involved with that. Now, if we go back here and we realize that we have a squared minus b squared, okay? Whoops. Isn't that what we have? Isn't this a squared minus b squared? Is that a perfect square?
Yeah.
Yeah, it sure is. And so all I got to do is take the square roots and put them in there. So the square root of x squared is x and x. Square root of 49 is 7. I have to have one positive and one negative. Because it's the difference of squares. So I have to have one positive, one negative. Okay? So on B, without using the old-fashioned method, 16y squared minus 81z squared, I'm going to drop two sets of parentheses. What is the square root of 16? 4. So I'm going to, and what's the square root of y squared? Y. So I'm going to put a 4y here and a 4y here. What's the square root of 81? And the square root of z squared? Z. So I'm going to put a 9z here and a 9z here. One has to be positive, one has to be negative. Let me just finish because we're running out of time. One has to be positive, one has to be negative. That's your difference of squares. Okay? Any questions on that? All right, let's do one last one, and then we'll pick up the other ones tomorrow. So the 3b cubed, whoops, 3b cubed plus 27b. Real quick, what can I factor out? 3b, leaving me with b squared plus 9 and then can I factor this part out?
Yeah.
Can I find factors of positive 9 that equal 0? 3 times 3 is 6. Negative 3 times negative 3 is negative 6. It can't go any further because this isn't a subtraction sign. If this was negative 9, then I could. So this is all I can go to. All right, on your way out. Actually, I tell you what. Okay, thank you. We're going to finish factoring special products, or at least part of it, before we jump into our quiz. We talked yesterday about nothing.
Mr. Melton, you started it. Now Jefferson's calling me fat.
I did not. Okay, you're over.
I didn't direct it towards you. I just said that.
Oh, really? That's the exact same way Mr. Melton. You know, I think I did that. Or do you want to call? Oh my gosh! Did you not hear him?
I wasn't listening. You guys leave Rihanna alone. She's not fat.
Oh, I'm trying to make it.
She's super skinny.
Such a jerk.
That's bad, dude.
Oh,
You can't say anything.
That's true.
She's underweight.
You are. All right, here we go. So, yesterday we were factoring special products. Okay, and we talked about the difference of squares. We talked about the different things that we should have been able to recall from our FOILing unit, when we were multiplying special products. Because factoring special products are essentially dividing that multiplied special product that we had earlier. So we worked on that a little bit yesterday. So I want to pick that up and finish that up real quick before we take our quiz today. Okay, I want to go ahead and review this right here. We had the x squared minus 49. Okay, x squared minus 49. And when we did that, we essentially took the square root of this. Square root of x squared is x, and stuck it in each parentheses. Then we took the square root of 49, which is 7, stuck them in each parentheses. And then what we realized was that because it was a difference of squares, we had to have one negative, one positive. Okay? Same thing applies for this one. The square root of 16 is 4, so I stick a 4 in each one. Square root of y squared is y, so I stick a y in each one. Okay? Then I have a difference of squares, so I'm going to have a minus and a positive. I'm just going to put one in each. Square root of 81 is 9. Square root of z squared is z, and I put those in each one as well. This only works if they're both perfect squares. Everybody follow that?
Yeah.
Okay?
Oh, we didn't do number. I mean, we didn't do hidden yet.
Sorry?
Oh, never mind.
Okay? So anyhow, I think this is where we're kind of going here. And yesterday, this is one we finished up on. We factored out the GCF first. So let me go ahead and let's do this one again. So 3b cubed. Whoop. So 3b cubed plus 37b. 27b. Okay. Oh, that's not even right. Okay, so what I did there was, first thing you have to do always, and again, I showed Nathan this morning how if you don't factor out the GCF, you can still work the problem. You can factor it out later. But when you factor out the GCF initially, sometimes it'll open up your eyes to the factoring special products. For those of you guys who take the time to memorize that and use that shortcut. But it always makes your problem easier because the numbers get smaller by factoring out the GCF. So the first thing I want to do is take the GCF out, which was what? 3b. They both have a 3 and a b in common. So once I do that, 3b cubed divided by 3b is
B squared.
b squared, right? Because 3 times 3 cancels, or 3 divided by 3 cancels. B cubed divided by b is b to the second power. Okay, because we do 3 minus 1 is the squared. 27 divided by 3 is positive 9. And then b divided by b cancels out. Now, what we were doing yesterday, just to kind of refresh you, because I know this was at the very end and we were rushing through it, but it kind of looks like a difference of squares because I have a perfect square here. This is a perfect square. And I have a perfect square here. The problem is what? Okay, it's positive. We don't have a sum of squares. There's no such thing as a sum of squares. It's the difference of squares. So that has to be a subtraction sign. So yesterday we took the time to say, okay, let's see if we can find factors of 9 that equal what? 0, right? Because there's no b term. So we looked for factors of 9 that can equal 0. And we found out that there was 1 and 9, negative 1 and negative 9. None of those equal 0 because this is 10 and negative 10. Then we have 3 and 3. That equals 6. And then negative 3 and negative 3. That equals negative 6. But I can't use negative 3 and positive 3 because why? It's not a negative 9. That's where that difference of squares comes in. If this was a negative 9, this would be easy. But since it's not a negative 9, we can't do it. And so since we can't do it, we are done. This is as far as we can go. Right there. Okay, any questions on that?
So it'll be like that for all of them?
No, I would never say it'd be like that for all of them. You have to. The hard part of factoring, the hard part of anything in math is you have to determine when it is what. It's never and ever just all of them. Sometimes it'll work like this. Sometimes it won't. Now, every time you have a perfect square plus another perfect square, chances are you're not going to factor anything out except for a GCF. Okay. All right. Let's go ahead and stop right there. We've been working on these special products, I guess now going on 3 days, only because we've kind of break them into pieces. Okay, so today we're on our last part. which is going to deal with this one here. This is factoring, if you remember this special product, okay, the special product is when you have A minus B times A minus B. Well, then your format turns into this right here. A squared minus 2AB plus B squared. So now what we're going to do is we're going to look for this form right here. And if we see this form already, so a perfect square, and then A and B times 2, then we can put it into that form right away. So let's go ahead and look at that. Again, these are shortcuts. All of these you can do using your normal factoring methods. You don't have to know how to do any of these shortcuts. You can use your regular method if you choose, but the shortcuts will help you. Now, to be honest with you, these perfect trinomials, because this is what this is, because that's what section you're on in your notes, the factoring the perfect square trinomials, I don't use this one very often. I just go ahead and factor, okay, like I normally would. But you can, thank you. You can use these shortcuts if you need to. So, let's look at the first one. We have x squared minus 8x plus 16. Okay? What's our a value? 1, right? So our a value is 1. And again, here's what we're looking for. Does it fit this? A squared. Sorry, does it fit? Let me give you a more visual example first. Does it fit this? A squared minus 2ab plus b squared. So let's go ahead and write that down. A squared minus 2ab plus b squared. That's what we're looking for. Does it fit that right there? Okay? And so, do we have that? If a is 1, what is b?
16.
Okay, well, b squared is 16, so what is b? 4, right? But it does fit that, right? Okay, now, if you have a is 1 and b is 4, what is 2ab?
Maybe 8.
It'd be 2 times
1 plus 4.
2 times
2 times
1 plus times 4, which is
8.
8. So does it fit our setup?
Yeah.
Okay, so if it fits our setup, then what we're going to have is what? Look back here. What was our factors of this setup here? A minus b times a minus b times a minus b. So if we go here and we realize that our setup works, what's our factors? X minus 4. And what? Sorry, JD? And x minus 4 again, right? Okay, hey, listen, you're not going to learn this if you don't pay attention. Just being completely honest with you. Okay, you're not going to learn this if you don't pay attention. X minus 4 times x minus 4. It's just simple memorization. Go back here. A minus b times a minus b. And always that a is going to have your variable, the x variable or whatever. And so then if it comes out to be a squared minus 2ab plus b squared. So what JD noticed was that it fit our format of a squared minus 2ab plus b squared. And since it fit our format right here, then we could go ahead and use the shortcut to get our answer. Now again, I did a lot of extra work on the side here that wasn't quite necessary. That work over there on the right side could just simply be mental math if you understand this relatively well. The other thing you could have done is you could have just gone ahead and factored. So if I was going to factor this like we have learned in here, How would I do that? What's my first step if I'm going to factor this like normal? Okay, find the greatest common factor would be the first step. Is there a greatest common factor? No. So what would be my next step? Drop your parentheses, right? How come I'm just going ahead and dropping my parentheses right here? Because there's no coefficient. Very good. Okay? So, using the normal method here, on this one, my first step is GCF, no GCF. So then I'm going to drop my parentheses, and now what? Put the X's in there. Now what? Okay, she's talking. Okay, find 16 what?
Factor 16.
Find factors of 16 that equal negative 8. Okay, so what are those? What are two factors of positive 16 that equal to negative 8? Negative 4 and negative 4. What do I do with these? I plug them into parentheses. And notice, the same answer, right? So you can see that it's just as effective and just as quick to do it this way than it is to do it the first way. I think part of the reason that we spend time on special products in this particular campus is because a lot of the teachers teach solely rooftop. Well, if you do this method here, it's a lot quicker than rooftop. Okay? But if we do this method here, it's about the same. Now, with the coefficient, if we can avoid rooftop, we can. We will. All right, so let's look at another example. Our next example is 25x squared plus 30x plus 9. Okay, what's our A value? 25. Our B value?
3.
Okay, so if we're going to go to A value, then our A value is not, okay, our A value is, well look, let's go back. Again, you've got to memorize this right here, look. The A value and the B value are what? Squared. Okay, so we can do 25, but understand that it's 5, and B is 9 and 3, right? We follow that? Okay, now, what is 2AB? What should 2AB be? Based on this, what should 2AB equal? 2 times 5 times 3, right? So 2AB would equal 30. Where's 2AB located in our trinomial? It's the middle, right? So does it equal 30? Yeah, so this is a perfect square trinomial, right? Okay, so the question now is, what goes in the parentheses?
That's A plus B times A plus B.
Okay, so A plus B times A plus B, okay. So, what goes in the parentheses then?
5 plus 3 times 5 plus 3.
Okay. Not just 5 plus 3, because we always have to have what? X. So 5x plus 3 and 5x plus 3. And again, you could also, if you wanted to, you could also rooftop. Okay? We're not going to go through that process to save time, but if you had to, you could rooftop. Okay, let's look at one more. You have 4x squared plus 40x plus 100. What do you do first? Yeah, GCF is always first. So what can you pull out here? 4. So that leaves you with what? X squared plus 10x plus 25. Okay, now, I'm not done. A lot of you guys are stopping after you pull the GCF out. You now need to be able to go ahead and look for that perfect square trinomial, or go ahead and rooftop if you have to rooftop, or just factor. You still have to try to factor this term right here. You still have to try to factor that. You can't ignore it. It's not done just because you pulled out a GCF. Okay? So now, what's the A value? We're not going to write this down. We're just going to try to do it mentally. What's the A value? Okay? It's 1 or 1x. What's the B value? 5. What should be 2AB?
10.
Okay? Because you're doing what? 2AB is what? 2 times what? What is it specifically? 2 times 5 times 1, which comes out to 10, right? Don't assume that it's going to work every time, because some of you guys are just throwing out numbers because you're like, oh, this is the notes. It's 10 because it's 10's in the middle. You got to check it. You have to check it. So is this a perfect square trinomial? Yes. So if it's going to be 4, what is going to go in my parentheses? X plus 5 and plus 5. And again, that's the shortcut method. If you can do that quickly, it makes your life easier. Okay, any questions on that? I want to show you one last thing, and then I'm going to let you go ahead and work. You can also write, and this is just a notation issue, how could I rewrite x plus 5 times x plus 5?
X plus 5 squared.
X plus 5 squared. Okay? These mean the same thing. This is actually how you're going to see it quite a bit. Okay? Any questions on that? Again, here's the deal. This is my recommendation to you. Number 1 is you memorize these. You memorize those formulas, those steps, to be able to do it shortcut method, because it will help you when you get to Algebra 2, Pre-Cal, and so forth. Okay, it'll even help you in geometry at the end. Okay, but here's the thing. I know that this is what some of y'all's mentality is. Well, I'm good at rooftop. I'm just going to do rooftop for everything. You will hate life the further along you get in math if you don't learn some of these shortcuts. At least have them available to you. The more you practice them, the better you get at them. The better you get at them, the quicker they are. The quicker they are, the quicker your homework is, and so on and so forth. Okay? Does anybody have any questions over this? All right, so